All right, let's go ahead and jump into 4.2. It says we've seen some relationship between the sides of a triangle. Now let's look at the angles of the triangle. Assign each member of your group to draw either an acute or an obtuse triangle. Make sure both types of triangles are represented in your group. Draw the triangle below. So I ended up drawing an acute triangle. It says use your protractor to carefully measure all three angles. I got 50, 67, and 63. Write the measures of each angle in the appropriate location. It says find the sum of the angles in the triangle, write it below, compare the results with others in your group. When I added mine up, it was 180 degrees, and that's what the kiddos were getting in class as well. And my conjecture is I think the sum of the interior angles of a triangle is 180 degrees. Next one, it says let's see if we can prove it. Trace your triangle onto patty paper, label the angles A, B, and C, and carefully cut out the triangle. So tear off the three angles shown, arrange them so that all three corners are meet at one point. Tape your arrangement to the paper. And the space below, how does your arrangement show the sum of the angles of a triangle? Well, when you do those, it makes a straight line, and a straight line is 180 degrees. So that must mean that all the angles together make 180 degrees. Next one, go back to your original triangle in question 1 and use a ruler to extend one of the sides past the vertex. What is the measure of the new angle? So when I did that, I got 117 degrees, as you can see here. It says, how does the outside angle relate to the other angles inside of the triangle? How do you know this? Well, when we look at that, you can see the linear pair, the 63 degrees and the 117 add to be 180 degrees. We already knew that because linear pairs are supplementary. But also if you have 50 plus 67, that comes out to be 117 degrees as well. So it looks like those two angles that are on the inside and far away, they're called remote interior angles. They're going to add to be that exterior angle. Now putting this all together in the quick notes, it is the triangle angle sum theorem. It says the sum of the interior angles of a triangle is 180 degrees. The remote interior angles theorem, aka the exterior angles theorem, says the remote interior angles add to be the exterior angle. And we look at this, whenever you have a exterior angle, if you look inside the triangle, far away from that angle, the one that's not a linear pair with it, those two add together to get the exterior angle. So in this case, the 1 and the 2, the measure of 1 and 2 add to get the measure of 3. Now on this one, we're supposed to be finding out these angles. You can do it multiple different ways. I used linear pairs to find out that 47.5. And then once I had the 47.5 and the 82.8, when I take those away from 180, I'm ending up with 49.7 degrees. I decided to use linear pairs followed by the triangle angle sum theorem. I'm not a huge fan of the exterior angles theorem, also known as the remote interior angles theorem. So that's why I did it the way I did it. Now on this next one right here, it says that those lines are parallel. So if those lines are parallel, whenever I hear parallel, I'm always hunting out alternate interior angles, same side interior angles, corresponding angles, and alternate exterior angles. So with that, I was able to find out if that one was 52, then R was 52. And if we have R being 52 and the other one being 29, then we have 99 degrees left over. And once we have those two angles, those three angles at the top add to be 180, and I'm able to find out what's left over, which is 29. Now on number 3 here, this is just all of the angles inside of a triangle. So I knew that they all added to be 180 degrees. It has nothing to do with exterior angles. So I added them all up to be 180 degrees. And you end up getting x equals 12. On the last one, it says multiple choice. In the figure shown, which of the following is the greatest? So I took my my diagram and I just started adding the angles as I knew them. So I knew that if that was 60, then the angle that's a linear pair with it is going to be 120. And then I knew that if that's 120, then the remote interior angles will add to be 120. So the 75 plus whatever's left over gets 120. So it's 45. Could have also done the triangle angle sum theorem to get 45 left over. If that's 45, then the linear pair with it is 135. And then we're able to use vertical angles to get the 75 and linear pairs to get the 105 as well. Once you have all that, you find out that the answer is B. Okay, let's take a look at the rest. It says which of the following are true for the following figure, and circle all that apply. It says B, C, and E is 180. Yeah, those are all the interior angles of a triangle add to be 180. We have C and D. C and D makes 180. Yeah, linear pairs add to be 180. The next one is C plus E equals D. C plus E does not equal D. Those are not remote interior angles in an exterior angle. B and C equal F. B and C do equal F because that is remote interior angles adding to be the exterior. And then it says A, F, and D. Those are all the exterior angles add to be 180, but they don't. It's going to be a full circle on the outside, and that makes 360. Now, number 2, you could have also tested out numbers and put a number in for E, C, and B and figured out what was left out on the outside for the linear pairs and gone from there. On number 2, those are the interior angles of a triangle, so they're going to add to be 180. So I add them all up to 180, and when I solve, I get 28 for X. What tools could be used in problem number 4? Well, definition of complementary, I don't see things adding to be a right angle, so that's not it. Linear pairs are supplementary. You have two angles that make a line. Vertical angles, yeah, look to exist in there. Segment addition postulate, I don't seem to be adding together segments. And triangle angle sum theorem is all the interior angles of a triangle add to be 180. And that seems like it could be useful as well because we have a triangle there. So I did linear pairs for the 120 and the 60. I did vertical angles for the 30 and 30. And then I used the triangle angle sum theorem to say 60 plus 30 plus 2x equals 180. On this one right here, this one is forcing you to use the remote interior angles theorem, also known as the exterior angles theorem. So you know that 3x plus 2x has to equal the 4x plus 20. So when you set that up and solve it, you get x equals 20. What are two possible ways you could solve for x? Well, one of the ways is you could go over and say 130 and find out what's left over for the linear pairs. That would be 50. And then you have 50, 70, and x make 180. The other way is that x plus 70 has to equal 130. And when you do that, you end up getting 60 as well. And then lastly on here, let me go ahead and scoot this down so you can see the answer. There we go. This one is going to be a triangle angle sum theorem problem where you have all the angles inside adding to be 180. You just needed to know that that right angle was going to be 90 degrees. So you have the two angles plus 90 degrees equals 180. All right, hopefully that made sense. The summary, the most important parts of this lesson are that the sum of the interior angles of a triangle equals 180, and that the two remote interior angles add to be the exterior angle that's far away from the remote interior angles. Thanks for watching.